Welcome Math 095. Today we're going to start Chapter 7. Your tests for your first chapter are complete for most of you. We will look at those next week. So this chapter deals with graphing lines and talking about functions. So today we're going to look at the first section of Chapter 7, and that is the rectangular coordinate system, or as you guys know it as the XY graph. So this should be a review for most of you, but we're going to again look at the specific components of the coordinate system, and then we're going to talk about how to graph a point, name a point, as well as determine if a point sits on a linear line. Okay, so this is the rectangular coordinate system right here. The definition of it is that it contains a horizontal number line and a vertical number line. Our horizontal number line is known as the x-axis. Our vertical number line is known as the y-axis. So our y's go up and down, our x's go side to side. There are an unlimited, infinite amount of points that sit in this rectangular coordinate system. Each point is called an ordered pair. We name an ordered pair by where it is sitting according to the x values on the x-axis and then the y values on the vertical y-axis. So if we look at this ordered pair, 3, -4, okay, to find that point, this is our x, this is our y. This point right here is called the origin. Let's see if I can put a smiley face. Let's put a smiley face, the origin. Will it let me? I don't know. Might not be big enough. Nope. Okay. Well, that point right there is our origin. That is where we always start from. Origin means the original, the beginning. Okay. So we always start from here when we are plotting a point. Okay. So if we're going to plot a point, the ordered pair 3, -4, that tells us the point is sitting at 3 on the x, so we go over to +3. We don't put a point there because we have to then go to -4. -4 means we are going down the y-axis to -4. This is the point 3, -4. Okay. Because the x and the y-axis intersect at this point, the origin, it separates the coordinate system into 4 quadrants. Okay. We spell quadrant. Oop. That's an N. Okay, the first quadrant is right here, and we use Roman numerals to name it. So this is the first quadrant, then we go counterclockwise. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. In order for a point to sit in each one of those quadrants, it has to take on specific criteria of the x and the y. In the first quadrant, all of my x's are positive and all of my y's are positive. So our points will always be positive points. In my second quadrant, my x's are negative because they are to the left of the origin, but my y's are still positive. So all the points that sit there will have a negative x and a positive y. In my third quadrant, all of my x's are negative over here, and all of my y's are negative down here. And then over here in the fourth quadrant, we have positive x's and negative y's. So if you're asked to plot a point based off of these criteria for each quadrant, we should be able to know where that point is going to go before we even plot it. Okay, so to plot a point, we start at the origin. Remember, that is the center of the graph. We move left or right according to our x value. From there, we move up or down to go to our y value, and then we draw a dot, plot our point. So let's look at these 5 ordered pairs. -4, 1. So this is a negative x and a positive y. So this should be sitting in the second quadrant. Okay, so -4, we start at the origin, we go over 4 steps to the left, and we go up 1, and we plot the point, -4, 1. Second point, 0, -5. This is what we call an intercept. When our x value is 0, it means we cannot go left or right at all. So an x value of 0 means I stay right at the origin, and then I go down to -5. This is what we call a y-intercept because it is sitting on the y-axis. Number 3, the point +3, -2. So we have a positive x and a negative y. So we're going to be down here in the fourth quadrant. Okay, negative or +3, so we go right 3 to the x-axis and down 2. This is the point 3, -2. 5, 1 is positive, so we know that's going to be in the first quadrant. Okay, +5 for x means we go right 5 steps. +1 means we go up 1. This would be the point 5, 1. And then finally, -3, -3. That's a negative, so we know that's going to be in the third quadrant, which is down here. So from our origin, we go 3 steps to the left to the x value of -3, and 3 steps down to the y value of -3. This is the point -3, -3. Okay. When we are naming them and we don't know what they are and we just have the point, we still do the same thing. If we're naming this point, we always have to go down to our x value first, and then we go over to our y value second. Okay. So let's name these. We're looking at A, B, C, D, E, and F. Okay, so A. This is sitting in the third quadrant, so we know it has to be negative. So we go up to our x value first, which is -6, and then we go over to our y value, which is -3. B is sitting in the second quadrant, so we know it's going to have a negative x value and a positive y value. Our x value is -4. Our y value is +2. Our C is a point sitting on the y-axis. So since we did not, from the origin, we did not move left or right, our x value will be 0. We went down the y-axis to -2. D is in the first quadrant, so it'll be positive. Our x value is 5. Our y value is 2, so that is the point 5, 2. E is the fourth quadrant, so it'll be positive. So our x value, is 6. And then our y value is -4. And finally our F, this is sitting on the x-axis. So if we start at the origin, our x value is -2, but we did not move up or down at all, so our y value is 0. That is how we name a point and plot a point. All right, so we are going to be graphing these in this class, here in a couple classes. The first form we're going to be starting with is what we call standard form. AX plus BY equals C. A, B, and C are numbers. However, A and B cannot be 0. If A is 0, then A or 0 times X would cancel that out. If B was 0, B times or 0 times Y would be 0, and we wouldn't have a linear equation in two variables. We call this linear in two variables because each equation is going to have an X and a Y, which represents the ordered pairs that make up the line that we are able to draw from this equation. A solution to our linear equation in two variables is an XY ordered pair that makes the equation true, which then describes the ordered pairs that make up that line. Okay, so we have an equation in two variables, 2x plus y equals 5. We want to know, is the ordered pair 2, 1 a solution? Or in other words, if I graphed this line, would this point be part of that line? Would that be an ordered pair sitting on that line? Well, we know that this is an X, and we know that this is a Y. Here's an X, and here's a Y. So all we have to do to determine if 2, 1 is a solution or if it's a point on this line, we can plug in the X value for X and the y value for y, and we can follow our order of operations to evaluate and see if this equals a true statement. So 2 times 2 is 4, plus 1 should equal 5. Since 5 equals 5, we are able to say that this is a solution. Here's another linear equation in two variables, x plus y equals 4. We want to know, is negative 1, 5 a solution to this equation? So again, we have an x value of negative 1, a y value of 5. So x is negative 1 plus 5, that should equal 4. Does negative 1 plus 5 equal 4? It does. So negative 1, 5 is a solution to the equation x plus y equals 4. It also means when we graph this, we will be able to find this point on that line. There are many ordered pairs on a line. In fact, there are an infinite number. You could pick any x value and find out its y value that goes with it. We can choose any values for x. Okay, it doesn't matter what you choose. MyMathLab may tell you exactly which ones to pick. In any case, you can pick any of them. Okay, so if we're looking for the equation x plus y equals 4 and we want to find two more solutions, you can either pick an x value or a y value and solve that equation. It doesn't matter which one you pick. Traditionally, we pick the x values. So we already had an x value of negative 1 that was 5. Okay. An easy x value would be 0, because if I plug 0 in the equation, 0 plus y equals 5, 0 plus y is y, and that tells me that y equals 5. Sorry, this is 4. I'm sorry. This is 4. Let me fix that. So this would be that y equals 4. I knew something was going on there. Can't have two y values for different x's. Okay. From there, you can pick anyone traditionally, 1, 2, something that's pretty simple. So if we're plugging in or picking 1 for x, then we're assigning the value of 1 to our x value. 1 plus y has to equal 4. Why do I keep writing 5? This is a linear equation that we solved in the last chapter. Okay, if we're solving for this variable, we know we have to use our inverse operations. So I'm going to subtract 1 to get my y on the left by itself, and 4 minus 1 is 3. So we found two other ordered pairs. They asked us if negative 1, 5 was a solution, and we found that one to be true. And then we plugged in 0, and we got 4 for y. And then we plugged in 1 for x, and got 3 for y. We could continue this process for any number of x, and we would be able to find our solution for y. So here's a missing ordered pair. This is an ordered pair where they're giving us the x value, but we don't know our y. If we have an equation in two variables, then if they give us one of the values, one of the x's or one of the y's, we will always be able to solve that equation for the other variable. It's called finding the missing coordinate to complete the ordered pair. Okay, so in this first one, they are telling us that x is 2. So if my equation is y equals 6x plus 5, they're giving me the x value of 2. So I can replace x with 2 and solve this equation for y. Follow my order of operations. Excuse me. 6 times 2 is 12. And 12 plus 5 means y equals 17. So in this ordered pair and in this linear equation in two variables, if x is 2, y has to be 17. Part B, they just flip the value they gave us. Instead of giving us the x, they're now giving us the y value. So we do the same thing. Take the equation y equals 6x plus 5. But in this case, now we're going to be solving for x. So our y value is negative 7. And we have to use our inverse operations to solve this equation for x. So here's my x term, so I know I need to subtract 5. So negative 7 minus 5 is negative 12. We can divide then by 6 to get x by itself and numbers on the other side, and negative 12 divided by 6 is negative 2. So my second ordered pair is if y is negative 7, x has to be negative 2. Okay. So that's the end of the lesson for today. Your homework for the next class will be to make sure these notes are complete and also complete the 7.1 My Math Lab assignment. Do the next class at your class time. Have a good day.